Hi, this is Mrs. Tratner, and I'm putting together a little video here on graphing position and velocity versus time. There have been some questions on this, so I thought that putting a little video together might help. So let's take a look at this. So when we're sketching position versus time, it's the same thing as distance. Position and distance always goes on the y-axis, and time always goes on the x-axis. So let's take a look at a couple of these problems, okay? They're very similar to the ones that you had to complete. So you are hungry, and you walk 4 meters to the kitchen at a velocity of 3 meters per second. Pause by the refrigerator for 3 seconds, then walk back, I should say, to the couch, apologize for that, with a bowl of carrots at a velocity of 2 meters per second. So all you have to do in this particular problem is sketch out what that graph would look like. So if you are walking, so you get up off the couch, so you're starting at a position of 0, you're going to walk to the refrigerator and you're going to stop. You're going to pause for a period of time, and then you're going to walk back to your starting position. So remember, when we have these kinds of graphs, it usually starts at 0, right? Because you're not moving, and then you're accelerating, and then you pause, okay? Your distance or your position doesn't change, but time continues to move on, and then you walk back to the couch. So that's how you would sketch a problem similar to this. Okay, so let's take a look at another problem. A bus is driving down the road at 35 miles per hour, and after getting a flat tire, moves 20 miles per hour. Okay, so again, you have a bus that's moving, right? So it probably stopped, and then it started to go, and then it got a flat tire, right? So it probably paused for a brief period of time, okay, and then the bus decreased its speed, okay? So it would look something similar to this. So again, the bus increases, it pauses, this line might be a little bit longer, like a little bit flatter, and then, let me just draw this one again. So if the bus increases to a speed of 50, let's say 55 miles per hour, okay, and it's going to go at a constant speed, okay, for a period of time, then it's going to get a flat tire. So it's going to stop, and then it's going to continue on again at a decreased velocity, okay? So when we look at this, here we see the increase in speed. The bus is continuing to move at a constant speed. It's stopping in here, and it's, kind of pausing, but then it'll go again at that rate of 20 miles per hour. So your graph could look something similar to this, or another way to draw it could be that, like I showed the other one, like this. Okay, it goes to 35, then it kind of pauses, and then it continues on. Okay, so here is where that flat tire would occur, and it would pause. Most of the time you're going to show that decrease in acceleration. So most oftentimes your graph, and I accepted either one, is going to look similar to this, and then it's going to continue on that way. This is showing where the flat tire is. This line here is showing that the acceleration, the 20 miles per hour, has decreased. Okay, so let's take a look at this one. This one kind of threw people too. A monkey picks up a rotten banana sitting on the ground and throws it across the yard at high speed. Okay, so if the monkey might not be moving very much in the beginning, but then starts to move. Oops, let me just get that again. Okay. Okay, so the monkey is kind of slowly walking, stops to pick up the banana, okay, might change here just a little bit, and then throws the banana at high speed. So this, and I know it's not a great line, is where that monkey stops and picks up the banana to throw the banana. Now, hang on. Let me just, let's just look at this because we're looking at graphing the monkey. This is my fault. So the monkey is probably sitting, walks a little bit, stops, picks up the banana, okay, and then might go back or stay where he is, okay, or walk slowly, however it is. This is where the monkey stops to pick up the banana. Okay, we're not graphing necessarily the banana being thrown. We're graphing the motion of the monkey. So you could have it so the monkey goes back to its position. Maybe the monkey stops because it doesn't say. So if the monkey's moving, he has to encounter the banana at some point. He might pick it up and throw it, but then just stay in that position. So this would be the point where he stops and throws it. It could be that he goes back to his position, his original position back by the tree. Okay, we're not necessarily graphing the banana that's being thrown. Okay, so I have one more. At track practice, the coach makes the team run back and forth between two lines 3 times. Okay, so they're stopped, they run to the line, then they run back and they stop. They run to the line, they run back and they stop. They run to the line, they run back and they stop. So each time here, they're stopped here, they're stopped here, they're stopped here. They are stopped here, they are stopped here, they are stopped here. So what this shows is that they run, stop, and then they turn around and they go back to their starting position. That's what this shows, okay? So then they stop, they run back to that same position, run back to start, run back, out, run back to start. So this would be an example of starting and stopping. So I'm hoping that this helps a little bit. I was pretty generous with the graphs. I was just looking for some, generals, like pieces in there, like did you show that something started and stopped? Did it go back to the original position? Things like that. So hopefully this will help in redoing that assignment if you want to. Examples are also given in Canvas. I put the PDF document in there, so there were examples in there, and I believe that I called it graphing. But if you continue to need help, come and see me and we will go through it. Thanks.